Hey guys, welcome to your final video of the semester. This is the last type, it's not the last type, but this is the second type of compound we're going to be talking about, or type of bond. These are known as metallic bonds, and so we're not going to spend so much time on this. I'm really just going to go over this for one day. It's going to be very brief and quick. In regards to your test is going to be mostly talking about ionic bonds in comparison to metallic bonds. But there's a few things I do want you to know, because obviously metals are a very nice commodity. We use them a lot in industry, so I want to make sure you have some understandings of why the properties are different for metallic bonds in comparison to ionic bonds. After this video, you should be able to describe the electron C model of metallic bonding, explain how metallic bonding is responsible for the conductivity and luster of metals, explain why metals are malleable and ductile, while ionic compounds are not, describe how metal atoms are arranged, and finally identify some common alloys and explain their importance. And so there's a lot there. Again, like I said, the information is pretty quick. There's not very many notes in here, so I'm just going to go through this video quite quickly, and I will tell you what I would expect you to know and what I don't really expect you to know. A couple things to keep in mind is, remember, we talked about ionic bonds in the last video, and ionic bonds are between two opposite charges. We are now moving to the idea of metallic bonds, and metallic bonds are the same charge. And so how do we have these types of characteristics when we have the same charges interacted? So first of all, we need to know about metals, and metals are found in crystalline solid forms. But unlike ionic compounds, every point in the lattice or in the structure of that metal bond is occupied by an identical atom, like charges. But the thing about these is that these valence electrons are what's known as like freely flowing. So electrons found in the outer energy level are free flowing and may drift towards another metal, meaning they have a little bit more freedom. They are not just attracted to that opposite charge. They are very much freely flowing. They're capable of drifting over and saying, hey, you're great, let's make a metallic bond. So they're more properly viewed as an array of positive ions surrounded by a whole bunch of mobile or moving valence electrons. And again, these are electrons that are capable of moving freely throughout this empty space within this specific bond. So a metallic bond is the attraction of the stationary metal cations to the surrounding mobile electrons. Remember, we are only dealing with cations right now because we're dealing with only metals. So all they're doing is these cations are attracted to whatever electrons they can get their hands on. All right, when it comes to metals, there are some properties I do want you to know in regards to metallic bonding. One, they are great conductors of electricity and they heat very well. And this is all because of those free flowing electrons. So as the electrons enter in, let's say we hook up some kind of device that allows electrons to flow. As electrons enter one piece of a metal, an equal number of electrons flow outward from the other end. And this allows that conductivity or that electrical current to freely flow quite rapidly. And it's that closeness of the metallic bonds that allow that current to flow really, really fast across all of those mobile valence electrons. Now, light, when it's shown on the surface of a metal, its electrons absorb small amounts of energy and become excited into one of its many empty orbitals. And so what's happening is that you have this luster on these metals, and that's all based off of those electrons and the energy that's associated with those electrons. And then if you remember when we talked about the properties of ionic compounds, we talked about how they're very brittle. Well, that's not so much the case for metals. These metals are very malleable and ductile. What that means is that they can be hammered into whatever shapes you want. They can be pulled into thin wire. And the reason for this is because those free-flowing electrons can slip in between stationary cations, and they can prevent from coming in contact with a force, if you will. So ionic compounds can't do that. Remember, we are shattering those bonds and we're causing like charges to come in interaction with one another. In a metal, those electrons can essentially hide, if you will, and that allows that shaping of those different metals. And then finally, the shape of what metals look like. Atoms are arranged in close packed structures, almost like a closet packing kind of thing. So they're very efficient, and so they have these nice cubic shapes to them. And last but certainly not least, let's talk about some useful ways we can use metals and metallic bonds. Alloys. An alloy is a mixture composed of two or more elements, at least one of which is a metal. So you're familiar with some alloys such as brass and bronze. So brass and bronze are not individual elements. They are not found by themselves. They are made up of different types of elements. So brass is an alloy of copper and zinc. Bronze is an alloy of copper and tin. So alloys are commonly used in manufactured items. For example, in musical instruments, whenever you want a specific sound, brass is very good for that type of sound. Bronze is a little bit of a harder metal than that of copper, and so it's very nice when you combine different metals, you get different sounds, you get different properties, as in like malleability and ductility. And also you got to think of price. Pricing typically for mixtures is a lot cheaper than it is for a pure substance. So steels are a very important class of alloys. I'm sure you've heard of steel for pretty much everything. The many types of steels are primarily composed of iron with small amounts of carbon, chromium, manganese, nickel, and so on and so forth. Steels are widely used in building, construction, and a various number of other things. Another thing about alloys, there are two types: substitutional and interstitial. And I don't expect you to know any more details than that in regards to the two types of alloys. Like I said, this video is going to be short and sweet, almost like I should have just talked about it in class, but it's all right. We got it covered. There's not too much information. The big thing in regards to this video I want you to know are the properties and why we see the properties we do. How are they different than ionic compounds? And these are all things we'll talk about in class. If you have any questions, please ask me on Edpuzzle.